Some planets are so hostile that our worst weather feels gentle by comparison. Across the Milky Way, astronomers have found worlds with glass in the wind, metals in the sky, and orbits that may end in destruction. But there is an important distinction. We have not filmed weather on these planets. Most of what you will see is inferred from light, chemistry, temperature, and orbital measurements. The visuals are artists' interpretations. The facts behind them are real, but the universe still keeps many details hidden. At first glance, HD 189733b might look almost inviting. Hubble measured it as a deep cobalt blue dot, a color that makes it resemble Earth from far away. But the blue does not come from oceans. It comes from a hazy, violently heated atmosphere, possibly mixed with silicate particles. Its day side is nearly 2,000 degrees Fahrenheit, and winds may reach about 4,500 miles per hour. Under those conditions, scientists say glass may rain sideways. May is the key word. It is a physical interpretation of the atmosphere, not a camera recording of falling glass. WASP 76b takes the idea of alien weather even further. This ultra-hot gas giant is tidally locked, so one face always points toward its star. On its permanent day side, temperatures rise above 2,400 degrees Celsius, hot enough to vaporize metals such as iron. Strong winds can carry iron vapor across the boundary into the cooler night side, where the material can condense. That is why researchers describe possible iron rain. They measured iron in the atmosphere. The rain itself is the best scientific explanation for where that iron goes next. WASP 12b is not just hot. Its orbit appears to be shrinking, bringing it gradually closer to its own star. This gas giant circles so close that a year lasts only about 26 hours. The star's gravity stretches the planet into an elongated shape. Hubble detected material extending far beyond the planet, evidence that the intense environment is stripping gas from its atmosphere. Transit measurements indicate an orbital decay timescale of roughly 3 million years. That is not an exact destruction countdown, but in cosmic terms, it is a death spiral in progress. KLT9b is so extreme that its dayside temperature exceeds 4,600 Kelvin, hotter than most stars in the universe. It is a gas giant, but it has been inflated by its star's radiation until its atmosphere puffs up like a balloon. 1 year there lasts less than 2 Earth days. The planet also follows a remarkably misaligned orbit, moving almost perpendicular to its star's rotation axis. NASA notes that the planet is constantly blasted by ultraviolet radiation and may be shedding evaporated material, like a comet tail. Then there's 55 Cancri E, a rocky super-Earth nearly twice the diameter of our planet, orbiting astonishingly close to a sun-like star. Its surface is likely molten, perhaps a bubbling global ocean of magma. It is also likely tidally locked, with one hemisphere facing the star all the time. Webb measured a dayside temperature of about 1,540 degrees Celsius, cooler than expected for a bare lava world. That may mean heat is being redistributed by a volatile-rich atmosphere. Researchers think gases could be bubbling out from the magma below, but the details are still being tested. Trace 2b is dangerous in a different way. It almost disappears into the dark. This Jupiter-sized world reflects less than 1% of the light it receives. That makes it darker than coal, and darker than any known planet or moon described by NASA's astronomy picture of the day. It is still a hot Jupiter, so heat can give the planet a faint red glow. But reflected light from the atmosphere is almost absent. Scientists do not yet know exactly why it is so dark. In a galaxy full of bright stars, this might be the closest thing to a planetary shadow. Finally, the first confirmed exoplanets were found around something that is not a normal star at all, the pulsar PSR B1257+12. A pulsar is the collapsed core left behind after a massive star dies. It spins rapidly and sends regular beams of radiation sweeping through space. In 1992, astronomers detected 3 planets in this system by measuring tiny changes in the arrival times of those radio pulses. NASA describes these worlds as exposed to constant radiation from their stellar remnant. They are a reminder that planets can form or survive in places that seem impossible. So which world is the deadliest? The answer depends on what you fear most. Vaporized metal, sideways glass, a magma ocean, darkness, radiation, or a star slowly consuming its planet. Every example on this list is real. The most alien details are often not invented by science fiction. They're hiding in the data from distant starlight. Which of these worlds would you call the deadliest? Tell me in the comments, and subscribe for more deadly worlds.